7.2 is on special right triangles. What I like about 7.2 is it's based off of the Pythagorean Theorem. What you can do is, instead of using the Pythagorean Theorem, these two shortcuts will save you time. As a matter of fact, if you learn these two shortcuts now, it's going to make your job in the next unit, Unit 7b, a whole lot easier, especially when we get to the unit circle, just to give you that preview. What you're going to learn are these two shortcuts. The first shortcut is called a 45-45 90-degree triangle. Looks like this. And the second shortcut is called a 30-60 90-degree triangle, which looks like this. These are shortcuts. These always work when you have angles that measure what these are called. For example, if it has a 45, a 45, and a 90-degree triangle, you can use S, S, and S root 2 to figure out what the sides are. The reason why this works is because of the Pythagorean Theorem. If you know a side, and it doesn't matter what that side is. Whoa, it has an eraser. I don't want that. I want the pencil. Let's do that. If I have the Pythagorean Theorem, and this is a 45 and this is a 45, most of you have already learned that this is an isosceles triangle. And if two angles are the same, then that the sides across for them also has to be the same. So what you have is, with a 45-45 90-degree triangle, you have a right isosceles triangle. And this squared plus that squared should equal that squared. Let's write that down. Don't write that down. I'm sorry. If I wrote that down, this is what it would look like. X squared plus x squared equals y squared. Now, if I put those together, you would get 1x squared plus another x squared is 2x squared. And if you're trying to figure out what this other side is, and you're trying to get that by itself, what you would do is you would square root both sides. When you square root the 2 and you square root the x squared would simplify, not the root 2. So the x would pop out, which is why this other side would be x root 2. What that means is no matter what your side is, if you know that this is S, S, the other side's going to be S root 2. Or if it's X, it's X, X, X root 2. Or if this side is 7, then this side must be 7, and this other side must be 7 root 2. That's how it works. It's very simple. You do not have much work to do other than to know what the pattern is. If you know that this side is 10 root 2, then you already know what this side is and what this side is. What does this side have to be? Tell the person you're sitting next to. What does that have to be? I heard a lot of you say 10. And if you know that that was 10 root 2, then the other side has to be. See how simple that is? That's how this works. It always works. And let me tell you what Mr. Paramo does for the 45, 45, 90. Because two sides are the same, two angles have to be the same. But I remember, since two sides are the same, that's why this one's always S root 2. Two things are the same. And that's the hypotenuse of this triangle. When I look at the 30, 60, 90-degree triangle, the pattern's a little bit different. Across from the 30 is S. Across from the 90 is 2S. Whoa. It is stop. No! See, this is why. Oh, look at that. Okay.
That needs to go.
Might have to use 7th period. I don't know. We'll find out. Across from the 30 is s, across from the 90 is 2s, and across from the 60 is s root 3. That's the pattern. It always fits that pattern. What is it based off of? It's based off of an equilateral triangle. Let's look at why it works. If you had an equilateral triangle, that means all three sides are the same. Let's just think about it being like this side is 2s, this side is 2s, and this side is 2s. They're all the same. You know what each angle would have to be, 60, 60, and 60. And then what would happen if you were to cut that equilateral triangle right down the middle? Boom, 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 boom. What would happen is that 60-degree angle gets cut to a 30, a 60, and a 90. That would be on a perpendicular bisector, by the way. And if this side was 2s, half of it would be s because this other side would be s. S, 2s. Well, what's that vertical part? Let's figure it out. S squared. The hypotenuse squared is 2s, and we can square that. It's 4s squared. You can subtract the s squared and get 3s squared. And then if you were to square root both sides, what you would get is the square root of 3 times the square root of s squared, and this pops out. The hypotenuse using the Pythagorean Theorem has to be s root 3. Earlier I told you that in the 45, 49, two things are the same. That's why it's root 2. For the 30, 60, 90, three angles are different. That's why I have the root 3 in it. That's how I kind of remember the differences between the two things. And so I go across from the smallest angle is s. Across from the 90-degree angle is double that. That's where my equilateral triangle comes from. And then s times root 3. And just like before, if I know that this is 5, you can figure out what the hypotenuse is. 2 times 5. You can figure out what this altitude thing is, and it would be 5 times root 3. How do you get your answers? You get your answers by just plugging it in. 2 times whatever s is. 2 times 5 is 10. Plug that in. You get 5 root 3. Does it make sense to you? If that makes sense to you, then this will all be easy. Your job really will be to memorize these two triangles so that you can use them at any single time during this worksheet. What we have, let's do example, and now that's the end of your notes, by the way. Let's go ahead and jump over to some examples. I want to start with number 7. If you want to pull out your packet and jump to number 7, I think that'll work. We're going to follow these 3 steps. Label each side by its angle it's across from. Figure out the value of s, and then use s to figure out the other 2 sides. So step number 1. 60, 90. Notice they only give you one angle. Can you figure out what this other angle is using a little bit of math? Do you know what it has to be?
180.
Altogether they add to 180, but what does this angle have to be? It doesn't give it to you. A lot of times it's only going to give you 2 of the angles. You have to do a little bit of math to figure out what the other angle is. And now you know it's a 30, 60, 90. Now what I recommend is you should know what it is based off of what's across from it. Across from the 30 in this example is s. I want you to put an s right next to what's across from the 30. Across from the 90, look at your example. What's across from the 90? 2s. So in this example, number 7, across from the 90 is 2s. What's across from the 60 in this example is s root 3. So I put s root 3 right next to the 20. And what this means is that since my given value is 20 and it's next to the s root 3, I have to figure out what s is based off of that information. It works like this. You write 20 equals s root 3. That's your equation. Label each side. Figure out what the value of s is. That's what we're going to do. We need to know what s is equal to. Well, how do we do that? Well, this is s times root 3. What's the opposite of times by root 3? Hopefully you're thinking divide by root 3. Root 3 divided by root 3 is 1s on this side. And this is 20 divided by root 3. I'm going to put it just a little to the left. I have a square root or a radical in the denominator, so I'm going to have to rationalize. When you rationalize, you do not have any radicals in the denominator. If you forgot how to do that, I will find the reference, but I'm pretty sure it's right around 0.2 or 0.3 notes. I need to multiply by root 3 over root 3. Technically, I'm multiplying by 1. Root 3 over root 3 is technically 1, so this is going to be the same thing as itself. Root 3 times root 3 in the denominator is root 9. Do you know what the square root of 9 is?
3.
The top, it has a whole number, a coefficient, and then this has a radical. You can't mix coefficients and radicals together, so you just write it as 20 root 3. If that's what s is equal to, then guess what? You now know what y is. Y is going to be the value of s. They're the same as each other. Y has to be 20 root 3 over 3. What about x? X is double whatever s is. So if I have s and I want to do 2s, then I have to double whatever 20 root 3 over 3 is. This doubling doubles the 20 only. So x has to be 2 times 20 root 3. That comes out to 40 root 3 over 3. I want to show you one other way to do this, just in case. Earlier we had 20 equals s root 3, and you divide it by root 3. The calculators I have recommended for you also do radical form. And in case you are stuck with radical form and you have 20 divided by root 3, these calculators rationalize for you. One of the reasons why I recommended this calculator at the beginning of the school year was because it did radical form in it. Not all calculators do this. So if you have one of the Casio's 300s or 115s, they work. The TI 30XS also works. But other calculators, like the iPhone calculator, doesn't do this. You're not allowed to use the iPhone calculator anyway. So you probably want to get a calculator that can do these functions and you're allowed to use on the test. Now, if I want to double that, I can put times 2 and get the 40 root 3 over 3 as well, just in case you want to double check yourself, okay? Example number 2 is number 13. Feel free to do this in your packet. A square has a diagonal length 13 meters. What is the length of the side of the square to the nearest centimeter? Ooh, a couple of things about this problem, and I'll throw it out there. Here's a square. Square I drew in red, so I probably should use a different color. Let me just go to blue. A square has a diagonal length 13 meters. The diagonal, the full length of this diagonal is 13 meters. What is the side length of the square to the nearest centimeter? Now notice that something happened on number 13. I just want to highlight it here. I'm going to see if you recognize it. If you recognize why the person who wrote this is trying to trick you, tell your partner, tell the person you're sitting next to what you notice about what I've circled and what that means that you're going to have to do. Discuss. I heard lots of good discussion. 13 meters. If I need to go to the nearest centimeter, should I write this as 13 meters? 13 meters is what? Is blank centimeters. I know most of you can do that. It's what? It's not 130. 1,300. It has to move 2 places. There are 100 centa. 100. Let's do that real quick, just because. 1 meter is how many centimeters? There's 100. Centa, meaning 100. The meters would cancel, and you'd be left with centimeters. 1,300 cm. Now, some of you might want to do this in terms of Pythagorean theorem, but there's no reason to. There's a shortcut here. This is what kind of triangle that we could use. It's a square. Do I have 2 sides that are the same? So what kind of triangle is this?
Right isosceles.
Right isosceles. This is also a 45, 90-degree triangle. It assumes you understand that about a square. And so now, instead of doing the Pythagorean theorem, instead of that, let's label this as S, this as S, and this is S root 2. If I want to figure out what S is, all I do is I set S root 2 is equal to 1,300 centimeters. I want the S to get by itself. What do I need to do? What is next to the S that I need to get rid of? What's the opposite of multiplying by that root? Will a calculator help me out here? And since we're going to the nearest centimeter, does that mean radical form? That means take it to a decimal. So we're going to need to make sure we can plug this into our calculator and convert it to a decimal. So I'm going to take my 1,300. I'm going to divide by root 2. Oh, you can't see that, so let's put that like that. And this calculator doesn't put it in radical form because apparently that's too big. And we need to go to the nearest centimeter. Does this round up or stay the same? (919 centimeters). So far, so good. Two more examples. I'll go a little quicker. Find the value of each variable. We're jumping to number 20. So when I see here on number 20 is I see a distance that's A, that this isn't a parallelogram, this is a trapezoid, and B, and I go B is not the same as 30, and I have a 10 root 3, and so you might look at this and go, how am I going to figure it out? The one key is that they have this here, and that we could take this and add something to this picture. What I would recommend that you do is I would draw a line. What would you use? Oh, come on. Give me a line right there. From here. I would add that if I were you. Now I'm adding that to my picture because that's the only way that you're going to figure out what this distance is, and I'm going to call it A. And I'm going to put a right angle here. I want to draw or find that altitude that's perpendicular. And this 30, I'm going to make sure that I know is 30 right there. That is 30, the full distance. But now what that does is it allows me to have a certain kind of triangle right here. Do you know what this angle's measurement is that I'm pointing at? How many degrees is it? So now you have a 30, 60, 90 degree triangle. What I would recommend is just like before, you label each side. Across from the 30 is, tell me what letter goes there.
S.
S. Across from the 90 is? S root 3. Across from the 60 is?
2S.
No, that's kind of hard to see, but I'm going to make it in there. What is given to me is this. 10 root 3 is the same as S root 3. 10 root 3 is on the same side as S root 3 because that's given. Now I can figure out what S is. Most of you, without doing any math, already know what S is equal to. You just use your logical brain. Some of you are going to want to do the math and want to divide by root 3. Go ahead. If you want to do it, go ahead. What's S equal to?
Isn't it the other way around? I think the
Oh, thank you. No? Yeah. Yes. Across from the 90 is what? That's where I messed up. You're right.
across from the 90 is 2S.
Messed up. Thank you. Across from the 90 is 2S, and then this is S root 3. Oh goodness, there we go. I messed up. I wanted it to be easier than it was. It's not. Definitely going to use 7th period on this one. That's how it goes. But I would keep it just in case. I could screw up there too. If I have 10 root 3 is equal to 2S, and I need to figure out what S is equal to, divide by 2, divide by 2. S is equal to, does this reduce? Coefficient divided by coefficient. Good. 10 divided by 2. What happens to the root 3? It stays there. So now you know this distance. 5 root 3. Now how do I take that and plug it into this S root 3 side to figure out what this distance A is? The distance A is 5 root 3. You have to plug this whole thing in and then multiply it by root 3. Let's look at what that looks like. 5 root 3 times a root 3. I think you could do that. Is equal to A. When S is 5 root 3, you multiply by root 3. Root 3 is root 9. 5 root 9, which is 3. 15 is equal to A. Now, 30 is the full distance. 5 root 3 is this distance. So if I want to know what B is, I know this one's going to be a weird one. You have to do a little bit of subtraction, right? 30 is the full distance. This is that distance, 5 root 3. What do I subtract? Any ideas? If you have an idea, tell the person you're sitting next to. Let's see if you guys discuss it.
30 minus 5.
If you said 30 minus 5 root 3, you were right on the money. Can you put those together? Can you add or subtract radicals that are not the same? No, this is as far as you can get. As a matter of fact, if you forgot that, you can type this in and see 30 minus 5 root 3 and watch what your calculator says. It's 30 minus 5 root 3 because that's simplest radical form. You can figure it out as a decimal, but it leaves it in radical form because that's in simplest radical form. Last example. 22. Right triangle ABC has an area of this. The measure angle A is 30. The measure angle B is 90. What's the length of BC, AB, AC? Express all answers in simplest radical form. So I drew a right triangle. And in this right triangle, since I knew one was 30 and the other one was 90, I kind of had an idea. Oh, it's a 30, 60, 90. A must be the shortest angle. B is the 90-degree angle. So C must be the other angle, and how many degrees does angle C have to be?
60.
Good. Kind of an interesting deal here, but why I picked this problem is because you're going to have to figure out using your 30, 60, 90, which one is S? Which one is S? Across, well, let's do it this way. Across from the 30 is what letter? Across from the 90 is which one? That's the one I messed up on last time. Across from the 60 is? Get used to doing that because that's what this whole section is about. Now what that means is that we have these are the only lengths that we're given. We are not given anything else other than, now we know what the area is. I'm going to circle that. Bless you. The area is 32 root 3. How do I find the area of a triangle? I know a formula for that. The area of a triangle is, do you know the formula? 1/2 base times height. You've learned that since hopefully 5th grade. Maybe even earlier. So, since I don't know what the base and height are, let's plug in area real quick. The area of the triangle is 32 root 3. The base and the height I'm not sure of, but let's do this. I know the base and the height have to be in this ratio of S to S root 3. I'm going to plug in those values. I'm going to plug in the base as S root 3 and the height as S. Just like that. Now I'm going to simplify. I have 32 root 3 is equal to S times S is S squared. I have a root 3, and then I'm going to put this as over 2. I'm just kind of like simplifying it a little bit. I just multiplied the S times S. The root 3 and the 2 are there. And now what I'm going to do is I'm going to do the reciprocal. Instead of multiplying by root 3 over root 2, I'm going to multiply by root. Oops, erase that, Mr. Promo. 2 over root 3. 2 over root 3. By doing that, the root 3 over root 3 goes into each other one time. 2 goes into 2 one time. You'll be left with, on this side, s squared. On this other side, you have root 3 goes into root 3 one time, and you're left with 2 times 32. 64. To get s by itself, you have to get rid of that square. The opposite of squaring something is square rooting something. This is the same thing as the absolute value of s. It's equal to a positive and a negative, but because we're talking about a distance, distances are always positive. We can eliminate the negative value. The square root of 64 is 8. Technically, it's, like I said, positive or negative, but I don't care about the negative value here because we're talking about area and distances are positive. Okay, that's enough information to answer the question. What is BC? Blank. What is AB? Blank. What is AC? Blank. Now we know what S is. What is that? Let's go back to my picture. BC is how long?
8.
AB is how long? And remember, we can write our answer in simplest radical form. We just plug it in. What is it?
8 root 3.
And last one is?
15.
And by the way, these are all measured in centimeters because the area was measured in centimeters squared. So there we go. Hopefully that helps you.